number 3. Any question, doubt on question number 3? Okay. Then unfortunately last question is a bit of a boring question. Okay. So this is information provision providing kind of question. So M1, which is essentially the metal 1 layer, okay, that means the first interconnecting metal layer for aluminium in this case is normally composed of 4 individual layers. Okay, I had mentioned it briefly in the lectures here and there, but I have just compiled it all continuously here. So, okay, at least one of the layers, can you guys guess what is the job? Conduction, contact, right? Yeah. Then another one, what could it be? Adhesion layer, right? So, okay, let's say we have 3 layers when we talk about an aluminium metal layer. Okay, the first one is an adhesion layer. Means so to make sure that the metal sticks nicely. Okay, because metals sometimes don't like to stick nicely. This titanium nitride has 2 functions. One is acting as a barrier layer because, as you will see, silicon and aluminum can actually react with each other. Okay, so if silicon and aluminum are sitting next to each other, it will form this kind of a spike. Okay, so they can react with each other. The other job the titanium nitride can do is to act as a what? What else can titanium nitride do? Anti-reflective coating. Okay. So, and now let's look at the third component. Wow, I thought only aluminum was needed. Why does aluminum also have 1% silicon, copper, everything inside? Okay. The logic behind the silicon is aluminum likes to dissolve silicon, right? As I mentioned. So, if I already add silicon into the aluminum, the tendency of the aluminum to take in more silicon is reduced. So, imagine like a sugar solution. If the water is already saturated with sugar, you will not be able to add more sugar into it, right? Because it's already full of it. Similarly, if you already have silicon inside that is close to the solubility limit of silicon in aluminum, the tendency of this layer to attract and take in more silicon is reduced. Okay. The second component that we add is copper, because of what I talked about in the yesterday's lecture, electromigration. So, aluminum has high electromigration. That means when a lot of current flows through aluminum, the electrons can push the aluminum atom away. So, under high electric field, there is migration of the aluminum atoms, and they can cause defects and things like that. If I add copper inside, that activation energy for diffusion is higher. Okay. This electromigration is ultimately the reason you went out of aluminum and went to copper. Okay, but before we did the transition, we just added copper into the aluminum to make this electromigration resistance. Okay, okay, and then again on the top of that, we have our titanium nitride as an anti-reflection coating. Okay, so adhesion layer, then diffusion protection layer, then the aluminum layer, and then on the top, anti-reflective coating. Why do I need an anti-reflection coating too?
Standing wave effect.
You guys remember the standing wave effect and things like that? Okay, so I don't need to show you this picture. This is from the third year tutorial. We talked about when the light coming and the light going back interfere with each other and create standing waves and things like that, right? To eliminate such effects, as well as yesterday's lecture, I again talked to you guys. The width of the photoresist, etc., that is developed can again change when there is height difference and things like that. Basically, you don't want any significant reflection that cause photoresist development in places that you don't want it to develop. So 4 things, okay? Any doubts, questions, clarifications on this question? Those who did not listen to yesterday's lecture, please listen. Learn about electromigration. Okay, that is it, people. tutorial is done and here if you want to write the question.